Okay, let's talk about how we can find the equation for this exponential function that's been graphed here. So some things to note on this. I'm going to go ahead and walk us through the steps. They're really not that bad of steps. We'll get to the answer, and then we can talk a little bit later at the end of this video about how to clean it up and get the best answer. So initially, we want to note this is an exponential function. So it's going to fit into this form, y equals a times b to the x power, where x is our variable, it's up in the exponent because it's exponential. The next thing to note is where our horizontal asymptote is at. Now it looks to me like our graph is tailing off here to the left-hand side, but it's getting close to the x-axis. So that would be when y equals 0, which means there has been a vertical transformation for this one. Next, let's go ahead and use our y-intercept, because that's been given to us. It's a little bit of a strange one here, but it's 0 square root of 2. So that's an x value, and that's a y value. Let's go ahead and fill those into our equation. So we have the square root of 2 equals a times b to the 0 power. So 0 goes in for x, square root of 2 goes in for y. From here, we get the square root of 2 equals a times, well, b to the 0 power is the same thing as 1. So this tells us our value for a is just the square root of 2. What we can do with that is we'll take it back up to our original function and plug it in. So now our equation looks like this. Y equals the square root of 2 times b to the x power. It's not too bad, so far so good. From here, we want to pick out one additional point. And sometimes it helps to zoom in on the graph, really make sure you're hitting at integer values is the best. I think in our case, we have 2, 3. This point right here, that'll serve as a nice additional point for us. So again, very similarly, we have an x value, we have a y value given to us, or that we found. So let's go ahead and fill those in. So down here, we're going to go 3 for our y value, square root of 2 times b to the second power. Now we have an equation that only has the one unknown. We don't know what b is, so we have to do a little bit of work to solve down for b. I don't think it should be too bad. We want to isolate the b squared initially, so we'll divide both sides by the square root of 2. Now this puts 3 over the square root of 2 equals b squared. And from here, we still need to get b all by itself, so we need to get rid of that square. We'll apply a square root to both sides to accomplish this. So b equals the square root of 3 over the square root of 2. Now, like I said at the beginning, we're going to get to an answer, and that answer is just going to be take this value for b, put it right back into that function we've been getting, and we get y equals the square root of 2 times the square root of 3 over the square root of 2. That went in for b, all raised to the x power. So this is an answer that'll produce that, that graph that we were looking at the very beginning there, over on the left-hand side. However, that value for b that we found has like square roots underneath square roots. It's got a square root in the denominator. We could make that look a little bit nicer. If you don't care about doing that, or your professor doesn't, just give them this answer. It's a great answer. However, if you want to clean this up a little bit more, let's walk through those steps. So what I'm going to do is I'm going to use, I'm just going to go down here to b. And let's think about this. I think the easiest way to think about this is though, instead of square roots, if we use rational exponents. So because the whole thing has a square root over top of it, that'd be the same thing as a 1/2 as an exponent. Our numerator is 3 to the first power, and our denominator is the square root of 2, but we could think of that as 2 to the 1/2 power. Right? Again, the square root can be written as 1/2 as a rational exponent. Now, if we want to go ahead and bring these, that square root, or the 1/2 on the outside to the inside, we would multiply exponents, so we get 3 to the 1/2 power. But you would get 2 to the 1/2 times 1/2 would give you a 1/4 for a new exponent. Now, when we get done, we don't really want to have any square roots or fourth roots in the denominator. We don't want to have any radicals in the denominator. We would like to rationalize the denominator is what we say. So what we want is this exponent to be a 1 in our denominator. So to get there, I think the easiest way to do this is we're going to multiply numerator and denominator by the same thing. I'm going to choose to have 2 as our base for both numerator and denominator. But I want to add the exponents together because we're using the same base to get a 1. So we already have a 1/4. Let's use a 3/4 for the exponent over here. That way, when we add together 1/4 plus 3/4, we're going to get that 2 to the first power for our denominator. Our numerator is going to be 3 to the 1/2 power times 2 to the 3/4 power. Or equivalently, we could say that's the square root of 3, right? 3 to the 1/2 power times the 4th root of 2 to the 3rd power all over 2, and that was our value for b. So an equivalent answer we could give would be y equals the square root of 2, our same value for a, times our value for b could be the square root of 3 times the 4th root of 2 to the 3rd all over 2. All right, equivalent answers, they look different, but technically we tend to want to get that denominator without a square root over top the 2. But either one of these should produce that same exact exponential graph that we've given on the left-hand side. So I hope this will help out. Good luck.